Hi students, today let us learn homologous series of alkenes and alkynes. The general formula of homologous series of alkenes is CnH2n, where n is number of carbon atoms in one molecule of alkene. So this is some of the examples for homologous series of alkene. So as we all know that a double bond is present only between two carbon atoms, that is minimum number of carbon atoms for the formation of alkene is going to be two carbon atom. That's why the first member would be ethene, molecular formula C2H4, propene C3H6, butene C4H8, and so on. So here what we can observe is that the successive members of the homologous series differ by CH2 unit. That is to C2H4, if you add CH2, you're going to get C3H6, that is propene. Similarly, when you add CH2 unit to C3H6, we're going to get C4H8, that is butene, and so on. So that's why it becomes a homologous series. So one more aspect about homologous series is that they have similar chemical properties, but physical properties will differ because each of the successive series or each of the successive member, they differ by a molecular mass of 14 grams. Okay, so that's the reason, since the molecular mass is going on increasing with every addition of carbon atom, physical properties also will differ, because we know that whenever we talk about increase in molecular weight, then it affects the melting point, boiling point, or even density, viscosity, right? So that's the reason why physical properties of homologous series will always differ, whereas chemical properties will be same. Similarly, let us understand homologous series of alkyne. The general formula for homologous series of alkyne is going to be CnH2n minus 2. So the first member again is going to be ethyne. YNE refers to alkynes. Molecular formula C2H2. Propane is going to have C3H4, butane C4H6, and so on. Here again, when you look at the successive members, they differ by CH2 unit. That is, you add CH2 group 2, CH2 unit 2, C2H2, you're going to get C3H4. Similarly, if you add CH2 unit 2, C4H6, we're going to get C5H8, and so on. There's one sample problem. Write the molecular formula of third and fifth members of homologous series of carbon compounds represented by general formula CnH2n minus 2. So CnH2n minus 2, first of all, we should identify whether which of the function group it refers to. It refers to alkynes. And the next question would be third and fifth member. So we know that alkyne is the first member would be ethyne. So he's asking the third member. So the third member would be butane. So if ethane is the first member, then second would be propane, and third would be butane. So butane is going to have molecular formula C4H6. How you can calculate C4H6? We already know the formula CnH2n minus 2. And then he is also asking fifth member. So third is butane, fourth will be pentane, fifth will be hexane. So hexane is going to have C6H10 as its molecular formula. Thank you very much, students.